Hello again, this is Bunton with your Visual Functional Mathematics at Level 2, Section 2, Measuring. Today's lesson is Lesson 7 and the title is Plans and Elevation and Volume. But before we start, I just want to remind you that we are now applying formulas in most of the maths problems we're facing because you'll be expected to apply them in the examination. Also, as I'd advised you before, make sure you have your exercise books with square ruled lines, your pencils, sharp pencils or pens, your rulers, because you'll be expected to draw plans of structures you're supposed to describe and do calculations on. So, here goes. Plans and elevation and volume. The lesson will cover what plans and elevation are and what they are used for. Drawing plans and elevations from specifications. Calculating the volume of a shape by multiplying. How volumes are used in calculations. Finding the volume of prisms and cylinders, and working with plans, front elevation and side elevation. But first, here are the keywords you'll be expected to use and be familiar with. And they are plan, elevation, views, volume, 3D shapes, prism and cylinder. So let's start with plans and elevation. Plans and elevations are 2D drawings of 3D shapes. You might be asked to draw accurate 2D drawings of 3D objects. How you draw them depends on where you're looking at the object from. If you're looking at the object directly from above, the drawing is called a plan. You can see that on the drawing on the right of the screen. If you're looking at it from the front, it is called front elevation or front view. And if you're looking at it from the side, it's called side elevation or side view. Please watch the drawings carefully and make notes of the labelings. Let's look at example 1. Draw a plan, front elevation and side elevation of the shape on the right. The shape has been made from identical cubes. Each cube has a side length of 1 centimeter. 1 square on the grid is equal to 1 centimeter. Start with a plan. If you look down on the object from above, you only see 3 of the cubes. Please look at the image on the right. There are 2 cubes at the top and 1 sticking out from the side. The cube sticking out is lower than the other 2. Show the change in height by drawing a line on your plan, or you can shade it if you like. Secondly, from the front view, you see 4 cubes stacked one on top of another, and 1 cube sticking out from the side. The cubes on the top and the bottom are closer than the others, so draw 2 lines, and shade them if you like, on your front elevation to show the change in front and in depth. And then thirdly, from the side view, you can see all but 1 cube. One of the cubes is closer than the others. Show the change in depth by drawing 2 lines, or again shading it. Your drawing needs to be accurate. To make sure you use a ruler and a sharp pencil. And as I said, your notebook, make sure you have a square ruled book, because that way it's very easy to scale. For more complex shapes, you'll have to use the given dimensions when drawing plans or elevation. Example 2. An architect is planning an extension to a house shown on the right. Draw the side view of the house on the grid provided. 1 square on the grid is equal to 1 meter in real life. And if you see the drawing there, you can see the dimensions. 6 meters wide, 3 meters high, and 4 meters deep. In the front and the back is 4 meters high. And this is the side view of the house. So, how do we solve the problem? Start by drawing the dimensions you're given. You note that the extension is 4 meters wide. This is the same as 4 squares in your drawing. Secondly, you also know that the extension is 4 meters high at the back and 3 meters high at the front. You can now draw the roof by connecting the front and the back walls. Your finishing drawing should look like this one on the lower right. Practice question set 1, question 1. Draw the plan, front elevation and side elevation of the shape on the right. The shape is made from identical cubes with side lengths of 1 centimeters. And you have the 3 positions there you can use on your exercise books. Right. 1 square on the grid is equal to 1 centimeter. And there is the shape you need to draw. You see look at the plan, look at the front elevation, and you look at the side elevation. Question 2. Janine is camping outside. A sketch of a tent is shown below. Draw the plan, front elevation and side elevation of Janine's tent. Again, 1 square on the grid is equal to 1 foot in real life, and the specifications are there. You see the side elevation, you see the height of the triangles are 4 feet, the tent is 6 feet wide and 5 feet long. Answers to practice questions set 1. On the left, you see the plan, the front elevation and side elevation views. And then question 2, likewise, you see the plan of the tent, you see the front elevation, and then you see the side elevation, which looks more like a square or a rectangle. Volumes. You can calculate the volume of a shape by multiplying. Volume is how much 3D space something takes up. You can work out the volume of cubes and cuboids by multiplying the length, the width, and the height together. And look at the drawings on the right. You see the cube and then you see the cuboid. Cube is pretty easy because the dimensions are all equal on the edges. Example. Calculate the volume of the cube below, and the dimensions are 3.5 centimeters, 3 centimeters, and 6 centimeters. So, length equals 6 centimeters, width 3 centimeters, and height 3.5 centimeters. Volume, the formula for volume is equal to length times width times height. All you need to do, put in the figures, which is 6 centimeters times 3 centimeters times 3.5 centimeters. And your answer is 63 centimeter cubed. Now listen to this. The units are centimeters cube or cubic centimeters. In this example, because you're multiplying 3 lots of centimeters together, if the lengths were measured in meters, the units of volume would be cubic meters or meter cubed. Make sure that all the units are the same before multiplying the values together. This is essential, and if you remember, we've been working on this for quite a while now in other units. Okay, so please do not forget. Using volumes in calculations. You may have to work out volumes as part of a bigger calculation. Now this is important. In architecture and other engineering projects, people have to draw plans of what they want to do. But before they do that, they have to measure as well. And they have to do projects in bits. Somebody might design one bit of the project, another bit of the project, and they put them together. And this is the start of activities like that. So let's look at the example. Leon's fish tank is 0.9 meters long, 0.3 meters wide, and 0.4 meters high. He is filling it with water using a container that has a volume of 3,000 centimeter cubed. How many times will he need to empty the container into the tank to fill the tank? You will note that two different types of measures were used, meters and centimeters at the same time. So be careful. First, convert the sizes of Liam's fish tank into centimeters so that all the measurements are in the same units. 0.9 meter is equal to 90 centimeters, 0.3 meter is equal to 30 centimeters, and 0.4 meters is equal to 40 centimeters. Secondly, calculate the volume of the tank. 90 times 30 times 40 is equal to 108,000 cubic centimeters. And then thirdly, calculate how many times the volume of the container will go into the volume of the tank, which is 108,000 divided by 3,000, and that is 36 times. So in this calculation, you have to do 3 different activities to be able to get to your answer. So the more notes you make, the more you practice, the better. And most importantly, make sure you're aware of the units of measures that are being used. As soon as you see more than one unit of measure, you will need to convert. Practice question set 3. Calculate the volume of the shapes below. 2. Sarah has a suitcase that is 1.2 meters long, 0.7 meters wide, and 20 centimeters deep. What is the volume of the suitcase? Again, make note that 2 different units of measures have been used for Sarah's suitcase. So you need to convert first. And 3. George is buying gravel to put on his sideway. The driveway is shown below, and he needs the gravel to be 2 centimeters deep. He can buy gravel in bags that cover 1,000,000 centimeter cube, or 1,000,000 cubic centimeters. How much bags will he need to buy? And there is the driveway, 122 meters by 3 meters in size. Your answer to practice question set 2. Question 1A, 9,000 cubic centimeters, and B, 70,000 cubic millimeters. Question 2, 0.168 cubic meters, or 168,000 cubic centimeters. Question 3, he only needs 1 bag for the drive. Finding the volumes of prisms and cylinders. A prism or a cylinder has 2 identical faces at either end of its length. You can call one of them the base. This is crucial. As soon as you hear the word prism, think about both ends as being equal. And if you know your formulas, then you can work on it. Secondly, you can calculate the volume of a prism or a cylinder using the formula volume is equal to area of base times length. Example 1. Calculate the volume of this prism. First, work out the area of the base. And the area of base is 6 times 4 divided by 2. Remember? That's that's a triangle, is equal to 12 square meters. And secondly, multiply your answer by the length. Volume is equal to area of base times length. So that is equal to 12 times 7, which is equal to 84 cubic meters. Please study the diagram on the right. Example 2. Calculate the volume of the cylinder. First, work out the area of the base again. Area of base is equal to pi times radius squared, which is equal to pi times 2 squared. You know the volume of pi. Multiply that by 4 and your answer will be 12.566 square meters. Secondly, multiply by the length. That is your answer by the length. So the volume will be equal to area of base times length. So 12.566 times 6 is equal to 75.398 cubic meter. Remember, when you're dealing with volumes, you're talking about cubic measures. Okay, the base of the cylinder is a circle. Those little properties are very, very important to remember. Practice question set 3. Question 1. Calculate the volume of the prism drawn below. Note the base. Note that the sides are triangular. Note the height. The width of the prism will tell you the shape of the triangle. And then you can calculate. Question 2. Find the volume of a cylinder to 1 decimal place. That tells you that you'll be working with pi, so don't forget. A radius of 4 centimeters and a height of 7 centimeters. And B, a radius of 5 millimeters and a height of 12 millimeters. And then question 3. Simone drills a circular hole through a block of wood. The diameter of the hole is 1.5 inches. What is the volume of the wood that's left over? So you have to do 2 sets of calculations and find the difference before you'll be able to find the answer for question 3. Let's look at what the answers are. Question 3, answer for question 1 is 47.25 cubic meters. Question 2A, 351.9 cubic centimeters. B, 942.5 cubic millimeters. And question 3, 34.23 cubic inches. It's not a very long lesson today, but it's a very important one because you're now applying most of what you've learned back in the entry level and during level 1 course. But before we go, let's summarize what we've learned. You have covered the following. We now know what plans and elevation are and what they are used for. You can now calculate the volume of a shape by multiplying. We know how volumes are used in calculations. We know how to find the volume of prisms and cylinders. We know that drawing plans, front elevation and side elevations are important, and we have to draw to specification. So we have to learn how to draw to specifications. And before you go, finally, please attempt all questions I've given you and check your answers and correct all mistakes. And most importantly, do not forget, when you get it right, celebrate. Pat yourself on the shoulder. It's always useful for morale. And that's the end of our lesson today. I hope you've enjoyed it. Until next week,